sections. Last week we talked about linear measure, okay? And today we're going to talk about angle measure. Talk about the parts of the angle and how to name angles and all that good stuff. So we want to start out with what a ray is. Now, a ray is a part of a line having one endpoint extending indefinitely in one direction. I think there was a question on your homework last week that said a satellite ray. Well, to me, that's a ray, not a line. I think they want you to use a line. But a satellite is more like a ray because it has a point that begins and extends indefinitely in one direction. You know those little pins that you're not supposed to bring to school that have the red little dots? That's a ray, okay? Because it starts at the pin and extends indefinitely in one direction. So that is a ray. Here's a picture of a ray. We've got this ray MO. You could also name it ray MP. You have an endpoint and then it extends indefinitely. And when you name it, you always have to use the endpoint first, and then you can use any other point that lies on the ray. And then you have to put a little mini ray on top of it. So I could name this ray MO, and I put a little mini ray on top. I could also name it ray MP. Okay? I could not, however, name it ray OM, because if I named it ray OM, that would mean that I started here and extended indefinitely in that direction. So do you see why I couldn't name it like that? You have to use the endpoint when you name the ray, and then another point somewhere that lies on that ray. Now, opposite rays, okay? Those are rays, for example, BA and BC. BE is a ray, BC is a ray. They share that endpoint right there, and B lies between A and C, which means all 3 points are collinear with each other, okay? It ends up creating a straight line, all right? Some books call this a straight angle, okay? If they ask us to name angles, we will never name the straight angle, okay? We don't even really refer to it. But it is kind of a straight angle. It creates two opposite rays. But the thing you get from the fact that you're told that you have opposite rays is that those 3 points are collinear and that they make a straight line. And what is the degree measure for a straight, for a line? 180 degrees, right? Okay. All right. So an angle. An angle is the intersection of two non-collinear rays. Okay, those were two opposite rays, so they don't really form an angle. An angle is the intersection of two non-collinear rays at an endpoint. So we have two rays here, and they intersect at Y, which is their endpoint. This is called the vertex of an angle. Okay, the two sides that are rays are called sides. So it's two rays that intersect at a common endpoint. Those two rays are called sides of an angle. Now, when we name an angle, there's a couple of ways that you can do it, okay? If there's a number at the vertex, then you can use that number and call it angle 1. And you always put a little mini angle in front of it when you're naming an angle. The most specific way to name it is to use 3 points. 1 point on one side, the vertex, and then a point on the other side, okay? The middle letter always has to be the vertex. So I could name this angle X, Y, Z. I could reverse the letters and name it angle Z, Y, X. But Y has to be in the middle because it's the vertex. Now, there's a third way that you can do it, and sometimes you can name the angle just by its vertex, angle Y. But I say sometimes you can do that, and the reason it's sometimes is if there is more than one angle at that vertex, then you can't use that method. For example, if I had two lines that intersected, and we'll say this was Y, and this is X, this is Z, this is P, and Q. If I said angle Y, would you know which of those angles I was talking about? No. So there is more than one angle at the vertex Y. So I couldn't use Y. I have to be more specific. Does that make sense? Okay? All right. Now, there's 3 parts of an angle. There is the angle itself. Okay? So if you were told that a point lied on an angle, it actually on the physical part of the angle that you would draw. Okay? That's the angle. Then you have the interior of the angle. And that's everything that's encompassed inside the angle, okay? Inside here, everything that's encompassed inside the angle, not on the angle, but inside it. And then you have the exterior. Okay? And that's everything outside of it, okay? So those are the three parts of the angle. Okay, so let's answer these questions real quick. Name the points on the angle. Q, M, and N, right? What's the vertex of the angle? M, very good. Points in the interior of the angle. Okay, S and R. Points in the exterior of the angle. P and O. Alright, so that's the parts of the angle. Now let's answer some more questions. Naming all the angles that has W as a vertex. Name all the angles that has W as a vertex. X, W, D. Okay, now that's our straight angle. Okay, so we don't typically name that as an angle. Okay. There's three easy ones, real quick, real easy ones. Sienna. Okay, the easiest ones I see is angle 1, angle 2, angle 3. Now there's two more. Caitlin. Well, angle 5 doesn't have a vertex at W. Okay, angle 5, its vertex is D. So it has to have a vertex of W. So we took care of these three. Sienna. Okay, we've got X, W, Y going right here. You see how that's 1 and 2 combined, but it still has a vertex at W. So that would be angle X, W, Y. And there's one more. Sienna. ZWV? Yes, that's right. So here we've got ZWV. Now, do you see how I highlighted this angle, the two angles that I was talking about? Because to me, it's kind of hard to see when you have a bunch of black lines and on white paper, and it all kind of starts mixing together for me. I don't know if it happens to you, but it does for me. So if I take and I highlight what I'm talking about, it kind of pops it out so that I can see it. Okay, now I'm not encouraging you to write in your book. Okay, you might want to draw the picture, or if you write in your book and you highlight something, do it very lightly so it can be erased. Okay, but sometimes it helps it pop out and it makes it easier to see. Okay, next question. Name the sides of angle 1. Name the sides of angle 1. So this is what we're talking about, angle 1 right here. Okay, what are the sides of it? Caitlin. What'd you say? Well, X and Z are points that lie on the side. But remember, what makes up your sides of your angle? What are they? They're rays, right? So if I'm going to name the sides, I need to name them as rays. So if I were to name this side, what would it be? WX, because you have to go from the vertex out, okay? So it would be ray WX, and then what's the other side? Ray WZ. Okay, so those are the sides of the angle. All right, here's another one. Write another name for angle WYZ. Highlight it so it's easier for me to see. Angle WYZ. What's another name for that? Harley. Angle 4. That's easy, right? Could I reverse these letters and name it ZYW? Yeah, as long as the Y is in the middle. So angle ZYW. So that's two different ways that you could name that angle. All right. Name a point in the interior of angle ZWV. A point in the interior of angle ZWV. Y. Okay, good. Y. It lies inside. Okay. Easy so far, yes? Okay. All right. A degree is the unit of measure that we use to measure angles. Okay, and so we use a protractor in order to do that. Now I'm going to pass protractors out here in just a second. I'm going to show you how to use it first, and then I'll pass it out and let you try it on your own. Okay, now when you use a protractor, you see how I've got this little crosshair? The one I'm going to give you has a little gold circle that you can use. You always take and you place it at the vertex of your angle, okay? And then you align this side right here But anyway, you from the crosshair on to 180, you take and you put it at the vertex and you line it up along the side of your angle, along that ray. So if I move it over here, I'm going to put the crosshair right there at the vertex, and I have that side aligned along the 180 right there, okay? And then what you do is you're starting out at 0 degrees where this is, because you have not moved up. And so you're going to take and you're going to look, and it's going to get bigger and bigger. So you start with 0, 10, 20, 30, 40, 50 something. Okay, this measures it for me. But if I put it up here, it actually measures 52 degrees. Okay, measures 52 degrees. On the other one, I flipped it. Now, it's not flipped on your paper, but I flipped it because I wanted to show you how to use the other side. Okay? Alright. So here, I lined the vertex up at the crosshair, and yours will be the gold circle. And then this ray right here shoots off and hits the 180 mark. And so this time, I'm using the top numbers because I'm starting out here at 0 degrees, and I'm getting bigger and bigger. See, it's going 60, 70, 80, 90, 100, and it comes over here, and it looks like it's about 133, 134, okay, right somewhere in between there, okay? And so that's how you measure with that. So I'm going to pass these out, and I do want these back. Don't leave them on your desk. At the end of the hour, we'll pass them forward and put them up. If I leave them on your desk, they might accidentally get stepped on or something. But I want to show you a couple things about these. These are kind of handy because it's a compass and a protractor at once, but okay, so when you are using these, okay, you see how I've got the little gold circle? Okay, that's what you put at the vertex. You put that there, and then you need to have your ray so that it shoots off to the 180 mark, okay? And I always try to line my arrows up so I know that I've got my ray and my arrow and everything shooting towards the 180, okay? Now, since we have aligned this angle, the bottom part of the angle, that ray, is on the right side, we're going to use the red numbers. And it kind of makes sense because it's an acute angle, right? It's not going to be 100 something, 100 something degrees. Okay. So we look along the bottom numbers, and again, it goes up, and it is about 52 degrees. Okay. Try the other one to make sure that you know how to use it. Please make sure, everybody look up here. Make sure that when you line it up, it doesn't look like this. See how this won't work? This black ray has to be shooting right directly towards the 180 mark right there. Okay? Have y'all used protractors before? Anybody? Never? Huh? Okay. Well, I guess you'll get to use one today. Alright. So, we said that this first one was what? 52 degrees, right? And this one we found to be 133 or 134. I'll give you a couple degrees on either side. Okay, degrees. All right. Now I'm going to talk about how to classify angles. Okay, and this is something you guys should know already. You have your right, your acute, and your obtuse. Okay, your right angle always measures 90 degrees. Now, when we talk about the measure of an angle, we put a little m in front of the angle. So we'll do the measure of angle A equals 90 degrees. And you see how it's got this red box here? That's another way that will indicate that it's a right angle. So, you know, when you're looking at a worksheet or a test or your homework, and you just see something like this, and you say, you know what, that looks like it's right. You can't assume that it is. You have to be told that it measures 90 degrees. You have to be told that it's right, or there has to be a red box there, or you have to be told like you have perpendicular lines, okay, in order to assume that it's right. You can't just look at something and say, you know what, that looks like it's right. That won't work, okay? All right, your acute angle, I think of acute as small and petite, so it's your smaller, and the measure of this angle B here is always going to be greater than 0 and less than 90 degrees. That's the acute angle. And then your obtuse angle, measure of angle C, is going to be greater than 90 degrees and less than 180 degrees. So if we go back and we look at these, our first one that we measured was acute. And what was the second one? Obtuse. Okay, so let's easy. All right. And we talked last week about congruent segments. We also have congruent angles, and those are angles that have the same measure. If you are told that two angles have the same measure, angle NNP and angle QNR, both measure 25. If you're told they both have the same measure, then you can say that they're congruent, and vice versa. If you know that two angles are congruent, then you can say that they have the same measure. To mark it on the diagram, you use arcs. Okay? In line segments, you use dashes. In angles, you use arcs. And if there happen to be two different pairs of congruent angles, you would use double arcs, triple arcs, whatever, however you needed it. Okay? Like we did with the segments. So those are congruent angles, angles that have the same measure. All right, here's another big word, angle bisector. Okay, an angle bisector is a ray that divides an angle into two congruent angles. Now, we talked about a segment bisector last week. And if you have a segment bisector, where does a segment bisector go through? It goes through a segment at its midpoint, which means it breaks it into two congruent parts, right? Well, with an angle bisector, it goes through the middle. Now, there's not a midpoint of an angle, but it goes right through the middle, creating two equal angles, two congruent angles. Okay? So if this right here is an angle bisector, then this angle is congruent to that angle. So, if this right here was 80 degrees and this right here was an angle bisector, what does it make each one of these guys? 40. Okay? Alright. Here's the last example here. Actually, this is an example, and I'm going to show you one other scenario that you might see. In the figure, ray QP and QR are opposite rays, what does that tell me? They create a straight line right through collinear. Okay? I think it would be over here in the bottom. One of those drawers over there.
We need them right now.
Okay. All right. So we know that QP and QR are opposite rays. It says that QT bisects RQS. QT bisects RQS. So QT bisects RQS. What does that tell me? That these two are congruent to each other. Okay, good. All right. Now it says that the measure of RQT is 6x plus 5. It says that SQT is 7x minus 2. And I want to find the measure of angle RQT. Alright, so I'm trying to find the measure of this angle, okay? And so, what am I going to do? I want to find the measure of the angle. In order to do that, I need to find x, and then once I find x, I go back and plug in, right? In order to find x, what do I have to have? I have to have an equation, okay? And in order to have an equation, I need two things that are equal. Do I have two things that are equal? Yes, what's equal? These two angles, right? Okay, so I'm going to do 7x minus 2 equals 6x plus 5. Okay, and I'm going to solve for x. So I end up with x is 7. Now, is that my answer? No, and this is where a lot of you stopped on your quiz. You found x and you didn't go and find actually what they were looking for. I'm looking for the measure of angle RQT. So to find the measure of angle RQT, you have to go and plug in. Okay, and so it'd be 6 times 7 plus 5, which is 42 plus 5, which is 47. So the measure of angle RQT is 47 degrees. And notice I put the little m in front of the angle because I'm talking about what its measure is. Okay, everybody see what I did there? Okay. Everybody got that written down because I want to show you something else we don't have to erase. Any questions on what I did there? Yes. The opposite rays just means it creates a straight line. It just tells me that those 3 points are collinear. Okay? And this problem didn't really use that. The next one I'm going to show you does. Okay? Because I didn't really need that fact. Sometimes they give you extra information. Okay? But I do need this for my next question I'm going to show you. Okay? Alright. Everybody got that? Okay. Okay, now, new problem. Let's say, still this is an angle bisector, so these two are equal to each other. Okay? And let's say that this is 3x plus 2, and this is 8x minus 5. And I want to find x. A couple of things you need to think about. Okay? What's going to be true about all three of these angles, RQT, TQS, and SQP? They're going to equal 180 because a straight line measures 180 degrees. So that's why I needed to know that they were opposite rays, and so that we know that all together they create a straight line. Okay? And so the sum of all three of these angles is going to be 180, right? Okay. Now, what am I going to have to do here, though? What? This is equivalent to this one? Yeah. Okay. So we know that these two are both 3x plus 2. So do all three of these have a relationship? Yes, they're equal to 180. See, what I'm going to do is I'm going to double the 3x plus 2 plus the third angle, which is 8x minus 5, and then I'm going to set it equal to 180. And then from there I can go and find x. Okay. All right. Now, last thing, and this is in your book. Go ahead and open your book to your page. Page 41 is what your assignment's on. And I just want to kind of give you a heads up on a couple of things. Now, my suggestion to you is the first thing you go and do is look at your homework and which ones you need the protractor for. You probably don't have a protractor at home, right? So I would go and do those problems first. Okay? And everybody listen, because a lot of people tend to make a mistake right here. If you look at 5 through 8, and if you read the directions, it says classify each angle as right, acute, or obtuse, and then measure the angle with the protractor. Okay? So if it says measure the angle, or use a protractor to measure the angle, you're going to use your protractor. Okay? But then look at the next set of problems. It's wanting you to find some angles, like angle LKN, angle JKN. Okay? And it gives you algebra. You will not go and measure this angle with the protractor. You will get the answer wrong. Okay? You have to use the algebra in order to come up with it, like that very last problem that we did. Okay? So only use your protractor if it says measure the angle with the protractor, or if it says measure the angle. If it says find the measure, then there's probably an alternative way to do it. Does that make sense? Okay? All right. I don't know. No, but there'll be some like it. Usually what it does is it gives you a couple of easy problems. It's like, you know, if it goes, it does the same thing again. So, but you'll have problems like this. Can a what? Yes, a rate to go through the vertex. Sometimes it's got the same endpoint as the vertex, and sometimes it's not. But yes.